today we will try to teach you how to use command line interface for the network switches.
Let's see if we can pick this up.
You probably saw them in the lab.
These things. So each pair of computers has two. I guess usually, for some labs you'll be using both of them, but for others you'll just be using one. But I guess later in this lecture we can cover making sure that you're connected to the right computer when configuring. There are some ins and outs to these that you'll eventually pick up, but hopefully today we can pass some common mistakes that people have made so you can avoid them.
Yes. So I guess we jump into what the thing is actually. So it looks totally similar to the CLI that we were using as a bash shell on the last lab when we were talking to the computer to make it move, delete files, create folders, create users, delete users. The same thing you can do with the switch. The commands that are available there are different, of course, because switches do different jobs than the computers usually do. But nevertheless, you use the same language, basically some commands and parameters that modify the way the command operates. I guess I will show the
Kali down there.
So in order to get to the Switch CLI, we need first we need to start the Linux CLI, and then we use a special command which allows us to talk to equipment via the serial cables.
Right.
I guess this gray cable that you saw connected to the switch. It's very ancient technology, but
still in use everywhere.
Yes. Especially with the low powered equipment like microcontrollers.
And actually all Dell computers have a serial interface in the back, just for backwards compatibility, I guess. So what you'll be entering to communicate is this command, screen dev tty-s0.
But on this particular computer we have the switch connected to the port number 2, which is in the binary it shifts a bit, because we start counting from 0. It's tty-s1. So now
but when you do it, you should write tty-s0.
Yes. So as you can see, everything disappeared, but actually if you press enter, you will see the welcome from the switch. There is a lot of confusion on how to get out of this program when you're already running in it, because no matter what you type and press different buttons, it keeps you in there. So what you can do is actually...
So normally in Linux, when you need to exit a command, you push Control-C, and that will always escape you from wherever you are. But here, when you try pushing Control-C, it does absolutely nothing.
It actually sends the Control-C into the switch to handle, because it wants to be as compatible as possible and send almost everything to the controlled equipment. So they came up with a special
sequence of keys,
letters, and it's Control-A \, then it asks you if you really want to leave, and let me type it in so that you can see. So you press Control, at the same time you press A, and after that separately you press /.
I guess it's technically lowercase a, right?
Yeah.
Right.
So that's how it goes, and you exit from this screen. If you want to get there again, you can press up button, and the previous command from the history of commands shows up. You can press enter. If you do this close thing, if you just close out of the
window,
shell, yes, this command screen keeps running, and it keeps communicating with the switch. So if let's do something like we type something,
we'll
help.
We'll go over all these commands later. So
yes, so we close out of it.
So here we're closing out of the screen session incorrectly, and then when later we try to go back in and we push enter.
Yeah, actually nothing happens, because Or sometimes you see garbage on the screen. Currently we cannot reproduce it, but really, well, something happens, like you see, that type of stuff. It's because these two programs are actually conflicting right now, and most of it goes to the first one. So let's close out of it again. This is not correct way to use this. Always use this Ctrl plus A backslash.
Right. But if you happen to accidentally do this, we'll show you how to save yourself.
Yes, you can observe this behavior using this magic command,
which you should have used in the first lecture.
And as you can see, there are two commands running with the dftty s1, and we want to kill them. So one of the easier commands to actually stop such things is kill.
So basically what you saw is the screen command was running on process 5947 and 6001. So you can either kill those processes individually by kill and then the process number, or you can just say kill all screen, and that will go through and kill all of the screens that are running. So now if we do the PSUAX again, we'll see that there's no screens running. Yes. So if we go back and we get back into the screen command so we can now communicate with the switch, we'll see it works just fine. So I guess we've gone over this in a lot of detail, so we'll be very disappointed if we get questions like this.
It will clearly state that we didn't see what we told you in the lecture. Okay, I guess...
So we should go over some of the basic commands like help and tab complete and...
So...
could go back.
So when you just connect to the switch, it welcomes you with the name console and asks you to basically do either unprivileged commands that are available immediately, and you can print them by typing question mark. This is a help, basically. So whenever you are in trouble or you don't know how to continue typing the command, you just press question mark and the switch will show you the list of available things.
Right. So let's say even if you're in the middle of a command, and it could be a pretty long command, there can be several words, and you type the first two words, you don't know what the third one is or what options you have, so you type the first two words, then question mark, and it'll tell you everything you could possibly type
after that. So these are unprivileged commands. They were basically available to anyone who logs into the switch, and they cannot damage the configuration of the switch. They're usually things that you want to monitor, or you want to kind of see the name of the switch, something that is not really changing
exactly
the configuration. So one of the most useful commands usually is show, and now I'm pressing question mark, and here we see the parameters of the command show, and we can see, for example, show version. There are no more parameters to it, and here you go, you see the version of the software and hardware. Again, show. Let's see what else do we have interesting here. Show ports. There are some, Let's see which ones have jumbo frame enabled. And when you're typing the commands, it's not necessary for you to type the whole thing. You can start typing it and then press tab, and it will fill the end of the command if there is no collision between different commands.
You can do the same thing in a regular Linux environment. Let's say if you're copying one really long thing to another really long thing, you can just use tab completion. Again, as Dr. Dolby said, if there's no conflicts in names. So
let's see. So we see that jumbo frames are disabled. Now I guess we are done with the unprivileged commands. In order to switch to privileged mode, you type enable command.
So one thing you'll find out is that backspace doesn't work. So what you need to do is either push enter and then it will take you to the next line because you just sent junk to the switch, or you need to navigate over and then push the backspace button, and that will act as a delete button.
Yes, because delete does that thing.
Right.
Yeah. So backspace works
as a delete. Yeah. It'll take some getting used to, but.
So now we, as you remember, I typed enable. So this command enable, it switches the switch into the privileged mode. If someone set the switch up to ask you for password, at that point you will be asked for the root password or administrator password. This is needed in case you have environment where someone else can show up in your networking room and try to damage the system, and in general it's good to put passwords. But in order to not to actually put additional useless work when we just don't enable it. Yeah. Again, we can press the question mark in here, and as you can see, the number of commands available to you increased, and every of these commands usually have quite long subcommand space. There is additional thing to it. It's not only the commands but the modes of operation. Do we have a picture for it?
For what?
Like the modes.
I don't think so.
Okay, then I'll show you. So there is the state where we are now in the switch has additional permissions to do things, but at the same time you don't change anything, so it's mostly print only. And reboot, for example, reload command reboots the switch. But if you want to change something, you need to
enter another mode.
Another mode, yes, right. It's like configuration mode. So now we are privileged but normal mode, and if we want to change something in the switch, we type configure.
And you can see it up here. If you type configure, we enter configuration mode.
And yeah, this mode is kind of highlighted in here that you don't get lost. And in the configure mode, there are even more commands available to you. And one of the commands, for example, we can see is the VLAN. And as you can see, we entered sub-configure mode. It's like, technically it is the mode which kind of prefixes all your commands that you later type with this thing, but it looks like you entered it into some separate room where separate commands are available. As you can see, there is quite limited set in this room, and you can introduce VLANs, for example, by typing VLAN and then the number. As you can see, I quite often use the question mark. I just type the command, immediately I type question mark, and I see what's next. So let's say 34, question mark, no continuation. So we just introduced VLAN 34. In order to exit from this room, you just type exit.
At this point, you don't need to worry about what a VLAN is. We will, by the end of the course, you will be very familiar with what a VLAN is.
Yes. Yeah, the purpose of this demonstration is to show you how you can get into the mode and into the deeper mode. And
right.
It's like, what's the movie?
Inception.
Inception, yes.
So to go back, I guess to leave a room, to go up a level, it's exit.
And the command show, it's not available here actually. When you are in privilege mode, has additional parameters. Yeah, I mean, look at that. Very long list of things that you can print. And right now we can print the VLANs available in the system. and I'll just type it like that. So you see the table of available VLANs currently on the switch. I guess let's continue with the presentation now.
So I guess switches it'll take some time to get used to, but the more you work with them, the easier it'll be, and it's important for not just the labs, but also for the tests that you're very familiar with this. You shouldn't be spending lots of time trying to enter a command in a non-privileged mode and not knowing why it's not working and tearing your hair out there.
So now we'll show you some more theoretical information. So
I don't think I did this one.
Okay, let's go back. So most of these switches utilize the Ethernet networking technology, which was developed quite a long time ago and became quite popular and pushed out all other token ring and other things out because I guess it was easy to implement and it's pretty fast. So most of the Ethernet technologies using these RG45 copper cables, but in near future you will probably see a lot of optics, but we'll be operating mostly with these RG45 cables. A lot of people, when they configure the switches, forget that they need to connect things with the cables. So they try to configure the switch and ask us why it doesn't work, but actually it's like electricity. If you didn't really connect the cable between two switches, the data cannot go through the switches, they're not wireless. So make sure that you always connect the cables the way you want them to be connected.
So I guess an important takeaway is, well, I guess we can go to the next slide. So on the back of your computer you have an Ethernet port where you connect one of the Ethernet cables to it, but then there's also the configuration, the serial port. And it's important not to get them confused. So whichever switch, when you have your switch and you have the serial port coming out, that'll be connected to a computer, and that's the only computer that can configure that switch. So no matter how the Ethernet cables are arranged, or even if you have 10,000 connections going back and forth, the only computer that can configure this switch via this port is the computer that port is actually connected to, not any of the Ethernet ports.
Yeah, I think we can show it now. Like if this switch is not really connected to the computer, you see it, there is no Ethernet connection at all, but we are still able to configure it through this cable. And if we connect these ports to, I don't know, all the computers in the university, it doesn't matter, we still configure it through this wire. We disconnect it, we lose the connection to the switch.
So I guess it's important to keep track of not only which Ethernet port is your computer connected to, but which switch is your computer connected to. Because we've seen in the past students just configure the wrong switch, or try to configure the switch, but they're not really connected to anything.
So on this picture you see example of the lab, how you will need to configure connect actually the computers and switches together. And as you can see, there is Ethernet connections, and there are separate RS-232, which is like serial connections that configure the switches. And those are quite separate. Like these connections allow you to change the way the switch operates, and this will affect the way the data moves through the switches and to the internet. What sometimes happens is that people get confused what they are configuring, and they sometimes connect this cable to this switch and this cable to that switch, and they believe that they are configuring this switch, but actually they configure that switch. So if you see some magic happens, always try to trace basically the cable with your hands where it goes, and this will help you to be sure that you are configuring the thing that you believe that you are configuring. Right. Otherwise it's
confusing.
Really confusing that you do something and there is no effect. Someone else did something and everything falls apart. So back to the lecture. Here on the slide you can see the simplest Ethernet network. It consists of the switch, two computers, and two net cables connecting computers to the switch. So when computers talk over the Ethernet protocol, they exchange the frames, which consists of many fields defined in the standard, and the data that gets exchanged between the computers is the payload. It consists of between 42 up to like 1500 bytes, and there is additional information that helps participants of the network decide to whom the packet was addressed or the frame was addressed and how to deliver it across different equipment. And one of the two most important things are actually the address of destination and the address of the source of the packet, and they consist of 6 bytes, and these 6 bytes usually identify the MAC address. It's also known as a MAC address of the equipment. And as you can see on this picture, two computers have their well-defined MAC addresses. They are usually defined by the manufacturer of the network card, but in many situations you actually can maliciously or non-maliciously change those things and pretend someone else.
So I guess an important distinction is not that the computer has a MAC, but that the network card has a MAC address. So if you have two network cards, then you have two MAC addresses for those cards.
And in the future you can actually simulate many MAC addresses. Like one card may have several MAC addresses. It can pretend to be someone else. So MAC address initially was defined as something solid and unchangeable, attached directly to the equipment that you bought, to the network card, but as time was going there was new methods to use this information and new methods to change it. So now this thing is kind of changeable. Yeah, variable. But nevertheless it's still used and it should be unique within network. So if you have conflicting MAC addresses on the network, you will have a lot of problems. This is the Ethernet frame as it is represented by the Wireshark interception software, and as you can see you can analyze it in a high detail, I guess. And when you open up this Ethernet frame you can identify the addresses of the source, the destination, and some additional fields. Like in here we have the 0800 identificator of the IP protocol, which is carrying a CMP message. So if we go back to this slide, we have MAC address of destination, MAC address of the source, then there are VLAN related things, and basically the data that you send. Now we will teach you how to use the Wireshark software, which helps you to observe what's happening on the network. Let's go back to the switch.
So you can start Wireshark.
I guess first I will show how to find the interfaces that we can use. There is a special command in Linux that config, which shows you currently available interfaces, network interfaces. And if you run it, you will see that there is a loopback interface, which was introduced into Linux kernel to make an impression that the computer is always connected to some network.
Even if it's just itself.
Yes. So when the networking programs try to send something, there is no special situation when there is no connection. It can always send something to someone.
Right. And later we'll cover this, but for example, you see the internet address 127.0.0.1 with the mask 255.0.0.0. That is itself.
Yes, usually this is a self network, loopback network. The actual interface that we have on this computer is this ETH0 interface. This is quite common to name the network interfaces that way in Linux. So if you have more than one network card, you will have ETH0, ETH1, ETH2, etc. In this information, you can see that it also shows you what is the hardware address or MAC address of this network card. It's this one. There are IP addresses and additional information that we will learn to use later. So if you want to observe the data that passes through this card, we can run a special software called Wireshark, and we need to specify the interface that we want to use. And that's how you do it. And if you want the Wireshark to immediately start monitoring, you should add -k key. So let's run it. Technically, it's not good to run things as a root, but for the lab environment, we do this way. So that's why you see these complaints from Wireshark about being run as a root. So this is the interface, and as you can see, there is plenty of talk going on the network card. So let's take some packet and look what it consists of, like in this UDP packet. So in this screen, on the top like sub screen, you can see the packets running, and usually this is the easiest to use. And when in the part of the lab when you need to show us something, it's usually that screen that you use. And the second screen basically represents the packet in details, which are like in tree-like. So you can open up substructures of it. So here we have Ethernet packet, and there is a destination. And recognize that this is a Dell network card. If you want to see original MAC address, it's this one. And there are special bits that we will not discuss here. This is Xen-defined MAC address. We have an infrastructure in our server room which utilizes Xen virtualization, and we use Xen-defined MAC addresses to basically have some idea what, when you monitor it, we know that this is Xen originated traffic. Yeah, I guess, and inside of this packet there is address resolution protocol, and you will learn it in some of the labs, what's the purpose of this protocol. And it consists of the origin of the packet, the destination of it, and the IP addresses of the hosts that use this. Basically, this is a gluing protocol between IP and MAC level.
But again, don't worry about that now. We'll cover that in a lot of detail later.
Yeah.
But I guess, is there anything else from Wireshark? Or oh yeah. So
yeah, this is binary representation. If you decide to do advanced research, it will help you. Yeah, I guess that's it with the Wireshark.
Filtering.
Yes, so there are filters here, like we can say no TCP, for example, to see what. Why doesn't it work? Just TCP?
Is there a way to do? Okay. Yeah. It's not no before it. It's probably not equal to.
Not? Yes.
Okay, not TCP. That's it.
Yeah. Got mixed up. So it's all service protocols like and UDP. Then you can say
like IP. Was it IP.src is equal to something?
Let's say 192.168.100.51.
Double equal.
Yeah, now we filtered out the traffic belonging to this particular host, actually has IPv6 too.
Yeah.
But anyway, yeah. So that's the traffic.
You can see a whole list of them if you go into expression. You can see all of the different possible filters that you can have. But I guess we just showed you the ones you'll probably be using. Filtering by IP address and filtering by protocol type.
We can say ARP. And this is all ARP protocol things. And if someone pinging, we can do a CMP.
I don't think anyone's pinging.
There should be someone. Yeah. Who is that?
I don't know who 183 is, but 158 is me. We'll deal with it
Yeah.
offline. Okay.
Yes.